Hi guys, welcome to the today's session of design and analysis of algorithms. In this session, we are going to explain the topic Strassen'S matrix multiplication belongs to the module 6. Coming to Strassen'S matrix multiplication, the Strassen'S matrix multiplication is an efficient divide and conquer method for multiplying two square matrices of size n by n. It was developed by Strassen in the year 1969 and is known for its improvement in asymptotic complexity compared to the standard matrix multiplication. So, it was developed by the scientist Strassen. The name for that matrix multiplication is Strassen'S matrix multiplication. Right. Now, what is the problem statement here? Coming to the problem statement, in general, the matrix multiplication can be carried out with some number of multiplications and additions. In digital circuits, multiplication can be carried out by the sequence of additions. That is, if we reduce one multiplication means we are reducing some number of additions. So finally, in a matrix multiplication, if we reduce some number of multiplications, automatically it reduces the time complexity. So here our Strassen'S matrix multiplication is an attempt to reduce the number of multiplications in a matrix multiplications so that it reduces the time complexity. So here you can see the procedure of basic matrix multiplication. So you can see that A is a matrix and B is a matrix. Both are 2 by 2 matrices. So if I multiply these two matrices, I get another 2 by 2 matrix, which is nothing but C. So how the elements which are present in C can be obtained? So here C11 can be obtained as by multiplying A11 with B11 plus multiplying A12 with B21. That is, like this, we are multiplying A11 with B11 plus A12 with B21. In the same way, C12 can be obtained A11 with B12, A12 with B22. And C21, this can be obtained A21 with B11 plus A22 into B21. And C22, it can be obtained A21 into B12 plus A22 into B22. That is, if you observe these, by doing all these calculations, we can get the product of those two matrices. So here you can see each element calculation involves 2 multiplications and 1 addition. So totally 4 elements includes 8 multiplications and 4 additions. Now, in our digital circuits, if I want to perform 1 multiplication means number of additions. Suppose, for example, if I want to do the multiplication of 4, 3, if I want to do the multiplication of 4 and 3, let us see, my A11 is 4 and my B11 is 3. I want to multiply 4 and 3. So what I need to do, 4 3s are, that is, what we are doing is, we are taking 3 4 times in binary and I am going to add these 3 4 times in binary to get its multiplied value. That is what, how many number of additions that we are doing? First I am adding these 2, then I am adding these 2, then I am adding these 2. So I am doing 3 additions to get 1 multiplication number. That is, this multiplication involves some number of additions. This multiplications involve some number of additions. This involves some number of additions. This. So every multiplication involves some number of additions. So that's why if we reduce this number of multiplications, then we can reduce the time complexity. Even the additions number may be increased, but multiplication can be carried with a multiple number of additions. If we reduce 1 multiplication, then it automatically reduces the time complexity. Now, for general matrix multiplication, the time complexity recurrence relation can be represented as like this. If I solve this recurrence relation, we will get the time complexity as big O of n power log 8. When I simplified this, I'll get big of n cube. N is the size of the matrix. Square, here we are taking square matrices. So that's why we are representing the size with only a single element n. So if it is a 2 by 2 matrix, n needs to be taken as 2. Then the time complexity for a 2 by 2 matrix becomes big of 2 cube. Right. Now, if you see the Strassen'S matrix multiplication, how it reduces the time complexity by reducing the number of multiplications. So here I have taken A is one matrix and B is another matrix. I want to multiply these two matrices, then I get C matrix. How the Strassen'S matrix multiplication is doing? So it is going to divide the problem into sub-problems. In case of Strassen'S matrix multiplication, it is going to divide the problem into sub-problems. So it is dividing the problem into 4 equal sized submatrices. Those equal sized submatrices are A11, A12, A21, A22, B11, B12, B21, and B2. That is, first it is dividing it into 4 equal sized submatrices. Then it is going to divide it into 8 equal sized submatrices. So recursively compute the 7 matrix products using submatrices. So that procedure entirely is to be called as conquering, and then combining of these solutions can be done. So here it goes for finding these 7 product values, M1 to M7, and then these M1 to M7 are combined here to get the 4 elements which are present in the product matrix. Right. So here you can observe that this is 1 multiplication, 2 multiplications, 3, 4, 5, 6, 7. Totally 7 multiplications are involved. But in our general matrix multiplications, it takes 8 multiplications. So here we reduce 1 multiplication. By that, it reduces the time complexity. So here we are explaining the procedure for only 2 by 2 matrices. For 2 by 2 matrices, here we try to reduce 1 multiplication. If the n is increased, we can reduce more number of multiplications. Ultimately, the time complexity can also be decreased more if you take n size is more. Now, the time complexity recurrence relation for this Strassen'S matrix multiplication is represented as like this. When we solve this recurrence relation, we will get the time complexity as big of n power log 7. When I simplified this, I'll get its time complexity as big of n power 2.8. So which reduces the time complexity by n power 0.2. So the time complexity for general matrix multiplication is big of n cube, whereas the time complexity for Strassen'S matrix multiplication is big of n power 2.8. So which reduces the time complexity. And here, in case of Strassen'S matrix multiplication, what is the base case? If the matrices become sufficiently small, that is below a certain threshold, perform the general matrix multiplication to compute the products P1 to P7, and we will represent the final result. So this serves as the base case of the recursion. Strassen'S algorithm reduces the number of multiplications compared to the standard algorithm, which contains 8 multiplications. These 8 multiplications can be reduced to 7 multiplications. Like that, it reduces the time complexity. Right. So I hope that you all understood this Strassen'S matrix multiplication. Maybe you may worried about that, how to remember all these values. So for remembering all these values, how to write all these values and how to remember writing of all these values and all these additions and subtractions. So here I'm going to play a small video which explains about 4 points to remember the additions and subtractions which are involved in Strassen'S matrix multiplications. Please see the video and do. So here, ahead. First one is ahead. Diagonals we need to take, then last CR, that is the last column and last row. First CR represents first column and first row. So here this is a 2 by 2 matrix and this is another 2 by 2 matrix. Here, you need to remember when you are using row, you need to use plus sign. When you are using column, you need to use minus sign. So first point in our 4 points is ahead. So first here we are taking A, H, E, D. Next we are going to take the diagonals AD and EH. So E plus H. Right. Since last CR means last column. Last column is BD. Last column. Since it is a column, we have to take minus sign. First CR. First column. X AC. Since it is column, we will take minus C. EF. E plus F. These are all completed now. We need to write this one. Right. So I hope that you all understood how Strassen'S matrix multiplication reduces the time complexity when compared to the general matrix multiplication. Thank you for listening.